So in this video, we're going to be looking at simple and compound interest practices. So the first formula to remember is, of course, the interest. How to find the interest, okay, in a simple interest. So interest is represented by your principal multiplied by rate and your time. This is principal multiplied by rate multiplied by your time, okay? Then the second one is going to be computing for the total amount. That means that we're going to have a total amount A, we're going to get the principal, and we add the interest. So we're going to look at it in a very nice formula. So A, now remember that I in here is representing this PRT. So we're going to use that PRT instead of I. And if we're going to continually convert it into a very nice formula, we're going to factor P, then 1 plus RT. So this is now your formula to find the total amount. Okay, that's going to be your principal plus your interest. Okay, so now the third is, of course, your compound interest, which is represented by your principal multiplied by 1 plus R. Our time here is going to be the power or the exponent. Okay, so we have taken this already in our previous lessons, and I hope you are still following this part. So the first example here, it says here that find the amount of simple interest and the total owed or saved. The interest rates given are for 1 year. Okay, so let's look at number 1. It says here a 500 loan for 2 years at an interest rate of 15%. Okay, so let's look at our given here. The given is $500. That's your principal. The time is 2 years. And your rate is 15%, which if it is converted in decimal, it's going to give you 0.15. Okay, finding its interest, PRT. Our principal is 500 multiplied by 2 years multiplied by 0.15, and that's going to give you $150. Okay, so that's the interest. We found the interest. So the interest rate in here is going to give you $150. Okay, so now the amount owed, what we're going to do here is that we are going to look at the amount owed, which is represented by A, and that's going to give you the principal plus your interest. So following this very simple formula, let's put this in. 500 plus your interest, which is 150. Of course, it's gonna give you $650. So the amount owed here is $650. Okay, so we're done. The second example talks about a savings. Okay, so a savings deposit of 1,500 for 18 months. That's actually 1.5 years at an interest rate of 6%. So let's look at our given here. Our given here is the principal is 1,500, and our time, okay, T, our time T in here is equal to 18 months, which is also equivalent to 1.5 years. Okay, and our rate in here is going to be 6%. Converted to its decimal form is going to give you 0.06. Okay, so using the interest formula, that's going to give you 1,500 multiplied by 18 months or 1.5 years multiplied by 0.06. Okay, so that's gonna give you 135. Okay, so the interest is going to be 135. So here interest is going to be 135. So the amount saved here in here is we're going to use the same thing. Amount saved is going to be your principal plus your interest, so that's going to give you 1,500 plus your interest of 135, so that's going to give you 1,635. Okay, so that's your total amount saved here, 1,635. Okay. So in this example, it talks about a high school graduate that works full-time. So here she needs to borrow 1,500. So we know that 1,500 is our principal. And to attend the local junior college, but she won't be able to pay it back for 2 years. So our time here is going to be 2 years. So we are now asked to calculate how much will she have to pay back with these two loans. In Bank A, it says a simple interest with 18% rate is equals to rate. Okay. So in this case, let's calculate it. We're going to use this formula. A, at the end of 2 years, for simple interest, we're going to use principal multiplied by 1 plus the rate multiplied by the time. So our principal is going to be 1,500 multiplied by 1 plus the rate is going to be 18%. So converted to decimal, that's going to give you 0.18. Okay, multiplied by 2 years. So this is going to give us 2040. So here let's write it's 2040. Therefore, the interest in here, if we're going to remove the 1,500, it's gonna give you an interest of 540. Now let's look at the Bank B. Bank B says that it's going to have compound interest 12% per year. Compound interest is represented by A is equal to P1 plus the rate. Okay, so our principal is the same 1,500 multiplied by 1. Our rate is 12%, so that's going to give you 0.12 raised to 2. So this is going to give us 1,881.60. Here, let's write it down. 1,801.60. Okay, so the question here now is says, which plan should she choose? Okay, so given these two choices, we know that Bank B offers a better deal. So say, Bank B offers a lot better loan plan. Okay, that's very good. Another problem, if you deposit 4,500, so I think that's going to be your principal, 4,500 at annual 5% annual interest, that's going to be your rate is going to be 5%, or that's going to be 0.05 in decimal, and our time here is going to be 10 years. But there's another word in here, compounded quarterly, that's gonna give you 4. So let's find out. A is equal to be the principal multiplied by 1 plus the rate divided by the compounding period times NT. Here, 4,500 multiplied by 1 plus 0.05 all over 4 divided by 4 times 10. So if we're going to simplify this using our calculator, all of this is going to give you 7,396.287, but let's put it into its 2 decimal places only. So at the end of 10 years, A of 10, your money will be a total of 7,396.30. Okay, that's it. Problem number 2, if you deposit 4,000 into an account paying 9% annual interest compounded monthly, how long until there is 10,000 in the account? So this is very nice because it says here how long. It means to say we're going to find time in here. We have to find t, okay, which is totally unknown. But what are the given? First, we are given 4,000, which is our principal. And then we are also given the rate at 9%. In decimal form, that's going to be 0.09. And it says compounded monthly. So the compounding period is 4. However, in here, we do not know the time. So let's continue to look at our compound interest formula. So A is equal to P1 plus R over N raised to NT. Okay, so we also have our final amount in here, which is 10,000. So A is going to be 10,000. So let's put that in our equation. 10,000 is equal to 4,000 multiplied by 1 plus our rate is 0.9. Then divided by 4. And then we're going to raise this 4 times the time. We do not know that yet. Okay, so the first thing we're going to do is we're going to simplify this part. So 10,000 is equal to 4,000. So if we're going to simplify this is going to give you 1.0225, and still it's raised to 4t. Now let's divide everything by 4,000. If we cancel this one, it's going to be 1. So what is left on this side is going to be just 1.0225 raised to 4t, while here it's going to give you, I will leave it as 10 all over 4. So continuing the process, we're going to put both sides into logarithms. That's going to give you logarithms. So on this left hand side, I'm going to have 10 over 4, while here logarithm of 1.0225 raised to 4t. Okay, now logarithm rule. In order to solve for the time, we're going to put it in front of that logarithm. Let's continue with it. 10 over 4 is going to give you 40 logarithms of 1.0225. Okay, we're now going to divide both sides with the logarithm of 1.0225 for us to isolate 40, this one. Then this is going also to be logarithms of 1.0225. So cancel out, that what's left here is only 1. Therefore, that's going to give you 40 is equal to the logarithms of 10 over 4 divided by the logarithms of 1.0225. Okay, so we're going to use our calculator in here. So dividing it using our calculator, 40 is now going to give you 41 point, I will put the whole decimal in here, 04 7891, and we're going to both divide by 4 to once again isolate t, which is the time in years. So if we're going to be dividing that by 4, it's going to give us 10.295 11,973. Okay, so this is going to be in years. So what I want to do here is, this is now going to be 10 years, so the time is going to be 10 years. And what I'm going to do with this one is going to multiply it by 12 months. Okay, multiplied by 12, that's going to give me 3 months. Okay, so that's going to be the answer to that. So that means it will take 10 years and 3 months for the money to be 10,000, to be $10,000. Okay, so that is the great answer to this problem. So this next problem is almost similar to the previous problem that we had. So if you deposit 2,500 into an account paying 11% annual interest compounded quarterly, how long until there is 4,500 in the account? So let's look at it. Our P in here is going to be 2,500. Our rate, that's our rate is going to be 11%, but in decimal form, that's going to give you 0.11. Compounding period, n is equal to 4 again. And this amount is going to be the final amount, which is 4,500. Okay, compound interest formula is P1 plus R over N raised to NT. So we are going to just fill in this one first. 4,500 is equal to this one, 2,500, our principal, multiplied by 1 plus 0.11 divided by 4 raised to 4 times t. We don't know what is t yet. Okay, so first we're going to simplify this one in our calculator. Okay, so let's continue. 4,500 is equal to 2,500. This is 1.0275 raised to 4t. Okay, the same process like we did earlier. We're going to divide both by 2,500. Okay, so that's going to give, what is left on this side is only 1.0275 raised to 4t. On this side, we're going to remove this. We're going to just have 45 over 25. Okay, we can leave it that way. Then we're going to put both sides into logarithms. So here we have your logarithms of 45 over 25. This is also the same as 1.8. This one is equal to the logarithms of 1.0275 raised to 4t. Okay, the same rule. If we're going to find out the time, logarithm rule, we're going to put that one in front. So logarithms of 45 all over 25 is equal to 4t, the log of 1.0275. So dividing both sides with logarithms of 1.0275, the logarithms of 1.0275, this is going to be cancelled as 1. So what is left now is going to be 40 is equal to the logarithms of 45 all over 25 divided by the logarithms of 1.0275. Okay, let's put this into our calculator. So here, after putting it in our calculator, we're going to be coming up with 21 point. I'm going to put the whole numbers, all numbers, 2507, and we're going to divide again by 4 to isolate the time, and that's going to give you 5.41. Okay, 5.41 6656 267. Okay, so what I'm going to do in here is I can say that this is now your 5 years, and if I'm going to multiply this by 12, I'm going to get 4 months. Okay, 4 months. Okay, so therefore it will take, Okay, it will take 5 years and 4 months for the money to be $4,500. Okay, so that's the final answer to that. Problem number 4, how much money would you need to deposit today at 5% annual interest compounded monthly to have 20,000 in the account after 9 years? So in here, we don't know the principal because of this word. How much money would you deposit? Okay, so we don't know this one yet. We're gonna find that out later. Then we have our annual interest, which is our rate is 5%. That's gonna give you 0.05 in decimal form. And also compounded monthly, the compounding is gonna be 12. Then we also have 9 years in here, which is going to be our time, 9 years. And our A, the final amount, is going to be 20,000. Looking at our formula, P is equal to 1 plus R over N raised to NT. Our A here is 20,000. We don't know our principal. 1 plus 0.05 all over 12 raised to 12 multiplied by 9. So 20,000 P. So after putting this one into our calculator, it should give you 1.5668 46649. Okay, so we're going to divide both side with 1.5668 46649. This is going to be cancelled out, and what is left is just going to be the P on the other side, and 20,000 divided by the same thing, 1.5668 46649. And if you're going to divide that, we're going to have a total of 12,764.49. But if we're going to estimate it, it's around 12,764. Okay, or let's say 65. Okay, this is going to give you 50, and whole number is going to give you 12,765. So that is actually your principal. So here's another problem. If you deposit 6,000 into an account paying 6.5 annual interest compounded quarterly, how long until there is 12,600 in the account? So let's look at our given here. The first that I see is going to be 6,000 is going to be the capital. Then we have the rate. It's going to be 6.5%. In decimal, it's going to give you 0.065 in decimal form. Okay, annual interest compounded quarterly. The compounding is going to be 4. And then how long? It says how long. It means to say we do not know the time. Okay, yes, we don't know the time. But in here it says that the final amount will be equal to 12,600 after a certain number of time. Okay, so compound interest formula, P 1 plus R over N raised to NT. Our A here is 12,600 is equal to the principal, which is 6,000 multiplied by 1 plus 0.065. Compounding period is 4, quarterly, 4 times T. So we are going to simplify this one first. 12,600 is equal to 6,000. Once simplify this one, it's going to give you 1.01625 raised to 4t. Okay, so we're going to divide both by 6,000. This will become 6,000. Okay, so 12,600 we divide it by 6,000. That's gonna give us 2.1. Okay, here. And here, what is left here now is going to be 1.01625 raised to 4t. So we're going to raise both to logarithms. This is logarithms. So on this side, you have the logarithms of 2.1. Here you have the logarithms of 1.01625 raised to 4t. Then we're going to find the time in here. This one, always remember, we have to put that exponent in front. Logarithm of 2.1 is equal to 4t, the logarithms of 1.01625. Then we're going to divide both sides again by this same logarithm of 1.01625 to isolate our time. Logarithms of 1.01625, this will be cancelled out. So what is left now here is just going to be 4t is equal to the logarithms of 2.1 divided by the logarithms of 1.01625. Okay, so we're going to use our calculator again on this part. So logarithms of 2.1 divided by the logarithms of 1.01625, this is going to give you 46.0276548. Then let's continue to find the time by dividing it by 4. Okay, so here the time now is going to be divided by 4. That's going to give you 11.5069137. So time now, it's going to take at least 11 years. 11 years. And how many months would that be? We multiply it by 12. It's going to give you 6 months. Okay, so to answer the question earlier, how long will it take? It will take 11 years and 6 months. Okay, so that's a very nice answer. Number 6 problem. I guess this is going to be the last problem in this video. If you deposit 5,000 into an account paying 8.25% annual interest compounded semi-annually, it means to say it's gonna be 2. How long until there is 9,350 in the account? How long? Another problem of time. So let's look at it. First, we have our final amount here, which is going to be this one, 9,350. Then we have our principal here of 5,000. And then we also have our rate at 8.25%, which is, when converted to decimal, that's going to give you 0.0825. Okay, and of course we have our compounding period, which is n equals to 2. Now the t in here is what is missing. That is the problem in this case. Okay, so let's find it out. Okay, a is equal to p1 plus r over n raised to nt. Our a here is 9,350 is equal to the principal, which is 5,000 multiplied by 1 plus 0.0825 all over 2 semi-annually and 2 times the time. So we're going to simplify this again using our calculators. Okay, so continuing is equal to 5,000. Once simplified, this is going to give you 1.04 125, and we're gonna raise that to 2t. Okay, let's now divide both with 5,000. So what is left on this side is just going to be 1.04 125 raised to 2t, while on this side, okay, this is going to give you 18.7 only. Okay, so we are going to raise both to the logarithms. Okay, so on this side you have the logarithms of 18.7. Here you have the logarithms of 1.04 125 raised to 2t. Okay, doing the same rule again, we are going to have here logarithm of 18.7. Here we're going to put this one on in front of it, so that's going to give you 2t logarithms of 1.04125. Then we're going to divide both by logarithms of 1.04125. Same with this one, logarithms of 1.04125, isolating to 2t. Therefore here you'll have your 2t is equal to the logarithms of 18.7 divided by the logarithms of 1.04125. Okay, we're going to use our calculator in here. So that's going to give you 72.44890699, dividing it by 2 on both sides to isolate time. So we're going to, that's going to give you 36.22445349. Okay, so it means to say that it's going to be, this is going to be the 36 years. 36 years, and how many months? That's gonna take at least 2 months. So the answer now it's gonna take 36 years and 2 months. Okay, so this is now your answer. So to summarize our lessons about compound interest and simple interest, we're going to look at the formulas that we have used. For simple interest, we have to first know its interest, which is simplified by this formula, I is equal to PRT. But if you want to find the total amount, that means it's going to give you the principal plus your interest. We're going to have a formula for this, and that's going to give you A is equal to P1 plus RT. So this is your simple formula for simple interest, and this is your formula for interest only under simple interest. For compound interest, here compound interest, we know that compound interest, it starts with that final amount is equal to the principal multiplied by 1 plus the rate divided by the compounding period multiplied by NT. So thank you so much. I hope you learned something about our short video on practices of simple and compound interest.